Okay, we're going to finish. I have one more thing I want to talk about before we move on. So I mentioned this last time, but it didn't really come up in the lesson. So if you have two functions doing weird different things, we got f of x, and then we have a different function. I don't want blue. I want a different color. G of x is doing this, and let's say that's 5, and I want to find the area between f and g. So what am I looking for? I'm looking for this area plus this area, right? So let's talk through how we would find that. What do you have to know? Where they intersect. So if this was in your calculator, you would put the first function in y1 and the second function in y2, right? And we know how to calculate the intersect on the calculator. Second, calculate, intersect, enter, whatever. When you do that, your calculator will say x equals and y equals on the screen, right? Let's say it's about 2.87. I'm making up numbers. Blah, 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 blah. Okay? How do I keep that number in my calculator? You have to store it as the x. Does it? It didn't work for me. I had to do it myself. So to store it, you quit back to the home screen, and then you can hit store, and you can store it to whatever letter you want. Well, you could store it to x, or you could store it to a, or whatever. You might not want it to be x. Yes, it will store this value on your home screen, and then whenever you hit a, you will have that number. So then I will call this a comma, and then I'm going to integrate from 0 to a. And on the test, you can do this. You can make a note over here that you're going to let that equal a, and then you can just write a for the rest of the problems whenever you mean 2.8, blah, 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 blah. So it doesn't, like you don't, on the home screen, when you type a bunch of numbers, there's not usually x's and stuff, right? You're just doing computations, so there's no variables involved. But when you're on the graph, there's x and y involved. So it's possible, Mason's saying that x just saves, which it probably does on the newer calculators. I think maybe it's the older calculators, you have to actually manually do it. And you could tell it to be x or a or whatever letter you choose. Oh, okay, that does not work on the 83s. So that's a calculator generation issue. Anyway, so now I have that number. I have it accurate to lots of decimal places, which is what I want. It's fine if you want to write that out to a bunch of decimal places and then keep writing it out, and then we're going to do it again right here, right? So in order to solve this problem, I need to integrate, not that, from 0 to a of f of x minus g of x. And then I need to go from a to 5, but this time the g's on top. So the f is first in my first integral, and the g is first in my second. And that's basically what you would write down. And then if they're really complicated, you would do it in your calculator and just type in your integrals, and type in your answer. And if they're not really complicated, you do it by hand. Any questions on that part? That's how to use the calculator. That's a home screen, yes. So variables are, that's just an answer. That's not x. If you hit x, enter, it won't be that number. It's not storing it as a variable unless you tell it to.
So on the second part where you're saying switch to g minus f, f minus g, like give the same value.
If you put a negative here, yeah, that would work too. And if I was doing it in my calculator, if this was a calculator problem, I could go from 0 to 5 of the absolute value of f minus g. But you can't, like, yeah. But you can't do that by hand, because absolute value, you'd have to figure out where it's positive and where it's negative, and you're basically doing this. So if you're doing it in your calculator, you can just tell it to do that. No. No. It is the absolute value of f minus g in where they are, around there, grouped there. You have to subtract them first. Well, it's more like if I have, so right here I have a positive and a positive. So it doesn't really matter. Well, it does. If I take 10 minus 6, or if I take 10 minus 6, am I going to get the same answer? Nope. So they're not the same. There's your fast version. Right. But this, in the calculator, it's going to move from left to right and find all those values and make them all positive and then add them all up. But we have to find them, all the positive ones, and add them up, and then all the negative ones and add them up. An absolute value? Because what's the antiderivative of the absolute value of something? You have to find where it breaks and do them separately, because you have a positive half and a negative half. Absolute value isn't a thing that we have a derivative or antiderivative of. I mean, the derivative of the antiderivative of 1 over x is ln of absolute value of x. There's an absolute value involved because we have to keep things positive, but not with derivatives. Okay, one more thing that I wanted to introduce but not go over too much yet is you can do all of this sideways. So if I wanted to find the area between these two, not functions, because they're sideways, they're not actually functions, I still can. Basically, you just turn and do it with respect to y instead of with respect to x. So in this problem, you would do the integral of f of y. So instead of having y equals x squared, you would have x equals the square root of y. You have to have it in terms of y. Yes. Yeah, so that's the simple version, is that this would be really hard to find the answer to if we look at it vertically, because these are points between itself, which is not even a function. These ones I could find, and then these would be really hard to find too. Same thing here. Like I could probably, not even, because it inverts. So you'd have to take the function and have the positive half of the function and the negative half of the function. It'd be a mess. So it's just a lot easier to just turn it sideways and go sideways. Example, if you have a function like that, that's the same thing as that, right? So you just solve it for the other letter. Yeah. So whichever way you're going, you got to make sure you have that letter involved, and this would be like your, whatever your functions are. I'm making two up. I don't know what they are. But these need to have y's in them. And that's why dy and dx, like, you got to say what letter you're talking about. And then what integrands would I have here? I'd be going sideways. So I'd go from, like, wherever that is to that. Not horizontally, but vertically, from here to here. So you just turn your whole thing sideways and then make sure it's got y's. That's the second half, so we'll do some more examples of that next time. F of y minus g of y is this, but that's just f of y and g of y. And that is the end of that.